Hello, grade 9. We're doing Geometry of Straight Lines, worksheet 2. When you are done with this, you must be able to solve problems involving angle relationships. And to help you with this, we are going to do a few examples. I suggest that you get your pencil, your book, your ruler, and you do the examples with me, because that will help you. So let's start with example 1. So in example 1, you are given this diagram and this information. They tell you it's straight lines AB and CD that intersect at T. So, straight line AB, straight line CD, they cross each other at point T. And what must you do with this diagram? You have to prove that angle T1 is equal to T3. Work on your diagrams, ladies and gentlemen. So I need to prove that this angle T1 is equal to T3. And I know you are thinking they are vertically opposite, and you know that they are equal. You are not allowed to use it. Please, this is very important. You have to prove it. So you must use something else to prove that. And the only thing you have in this diagram and with the information that they give you, that you have a straight line AB and you have a straight line CD. So you can only use knowledge that has to do with straight angle. And you have enough knowledge for that. If I look at T1 together with T4, it forms this straight angle CTD. So it forms angle CTD. And I know a straight angle, if I add the two angles together, it must give me 180 degrees. Similarly, for angle T3, I also know that T3 and T4, that add up to 180. So if I add T3 and T4, I must also get 180. And basically that's all you've got. So let's see how you can use it. I'm going to write the information that we've just talked about in a statement. So I'm going to start with CTD. And I'm going to say angle T1, and it's an angle, plus angle T4, add up to 180 degrees. And the reason why I can say that is that it's a straight angle, and that is given information. I can say it is straight. I'm going to abbreviate that to make it a bit quicker. It's a straight angle. So that is the statement that has to do with angle CTD. So the other straight angle I've got is this one. I've got angle T3, and if I add that angle T4 to it, I'm also going to get 180 degrees. For the same reason, it's also a straight angle. So I write my reason. Okay, so now I've got two statements here. And if you look at these two statements, we are going to use a little bit of logic to use this to prove that. Let me make it simpler. If I have a number A and I add a number B to it, and that gives me a number C, and I have a number A and I add a number D to it, and it also gives me the number C. What does that tell you? Because you're adding a number to A here, and you're also adding a number to A there, and it gives you the same answer. Can you see that it means that this number that you add to A here and this number that you add to D here must be the same number. They must be equal to each other. Therefore, you must be able to say that B must be equal to D. Otherwise, you won't get the same answer. Think about this little piece of logic. It's very simple and it makes a lot of sense. So we're going to use this with these two equations, because if you look at them, you will see that you have angle T1 plus angle T4 add up to 180. You have T3 plus T4 that also add up to 180, which means both of them add up to the same thing. So the left-hand side of this equation must be equal to the left-hand side of that equation, because they are both equal to 180. So let's write that. So I get angle T1 plus angle T4 must be equal to angle T3 plus angle T4. Just put my angles in there. You must not forget that because we're talking of angles. So, can you see that T4 is the same thing on both sides of the equation? So, the logic then that follows means that T1, angle T1 must therefore be equal to T3. Think about this, and because that is exactly what I had to prove. And I always look, did I prove what they asked me? And I can say yes, it's proved. T1 is equal to T3. I hope you get it. So let's do the next example. Example 2, you have to show that ABC is a straight line. So there is ABC, and you have to show that it's a straight line. What do we know about straight line? We know that a straight line is also a straight angle, and it is equal to 180 degrees. So if I look at this diagram, I have all these angles. Together, all these angles, if it's a straight line, if I add all of this together, it must give me 180 degrees. So let's see if that is in fact the case. So I'm going to write a statement, and I am going to say that angle X plus X plus 160 minus 2x plus 20 degrees must add up to 180. I'm running a bit out of space here. And the reason why they must add up to 180 is because that's a straight angle or a straight line. So let's see what we have on the left hand side of the equation. Let's see if it actually adds up to 180. So the left hand side of the equation is all of this. So let's add up. I get x plus x, which is 2x. Then I have plus 160 plus 20. So that is plus 180 degrees. And then I have this, minus 2x. So if I have 2x plus 180 minus 2x, what is all of that equal to? Yes, it is 180 degrees. Proved. Therefore, ABC is a straight line. And I can say because the angles add up to sorry about the writing, but I'm writing with my mouse and it's very difficult. But I hope you can read that. So I have proved what I wanted to prove. ABC is a straight line. It is done. So let's see if we can do another example. So in example 3, you have to calculate the value of x and y. So what have you got? Here's your diagram. You have a lot of straight lines crossing each other. So let's see. Here we can work with vertically opposite angles because we know that they are equal. So let's just mark all the information on the diagram. What does the square mean there? It means I've got a 90-degree angle. And can you see this straight line? I form a vertically opposite angle there, so it means that that angle is 90 degrees. Right. So then I have this straight line crossing this straight line. So I've got vertically opposite angles there. And you see you can already answer part of this question. And then you have this. So this must be equal to that. And in this one, this is equal to that. But let's just start with the first one because we can already say what y is. So I can say angle y must be equal to 32 degrees. Ooh. And the reason is how vertically opposite angles. Good. Then let's look at x. Angle x is not, we don't know what that angle is. We don't have it. But angle x forms a straight line. HI is a straight angle. I know what that one is and I know what that one is, so I can get x. So I can say, write a statement and say angle x plus the 90-degree angle, so plus 90 degrees, plus, there I have 32 degrees, that gives me 180 degrees. The reason is it's a straight angle. Right, so let's add this up. So if I simplify the left hand side, 90 plus 152 is going to give me 122 degrees. And that must be 180. Good. So solve the equation. I don't want that 122 degrees there, so I'm going to subtract it. And what I do on the one side, I do on the other side. And so on. What am I left with? It will just be x on this side. And on that side, I will have 180